First, I'm going to talk about the problem statement. A pullback toy car is one of the most common toy available on the market. We pull it backwards and then let it go, said Bobby 2014. It's traveled at a certain distance by itself before stopping, but if we observe it clearly, it's never traveled at the same total distance. Sometimes it might go further, but sometimes it just move a few inches ahead. The factor of the effect the total distance traveled by a pullback toy car needs to be figured out and find the best way or condition to make the car move further. The analysis of the experiment will be carried by using industrial engineering concept, which is design of experiment DOE application. Okay, next, there are four objectives of the project. First, to identify the factor that affect the total distance traveled by pullback toy car. Second, to analyze the relationship between the type of surface traveled by toy car and total distance traveled. Third, to analyze the relationship between the distance of toy car is pulled back and the total distance traveled. And fourth, to apply design of experiment DOE, which is industrial engineering concept learned in this course. Okay, about the background of study, the pullback car is a type of toy car which is commonly the kids play. It is ideal for helping kids understand physics, as it is easy to use in a few experiments. DOE is the series of tests which is involved change the controllable input factor so that the corresponding effect in the output response may be identified.
My name is Bea Patricia, and I will proceed with the literature review. So, the Cherokee, known as a penny racers, was made up of the squeeze images of real cars. It also had a pullback motor with a coil spring. The pullback car is made up of a chassis with gearbox, axles, and wheels that is encased in a metal or plastic outer shell. So, a pullback toy is based on the Newton's third law of motion, which states that each movement has the same reaction and the opposite reaction. So as per working principle pullback car, behind the biggest gear there is stored a twisted piece of metal which is called torsion spring. The more you twist it, the more energy is stored inside. Once released, it quickly unwinds and the car is propelled forward. Here on the large gear with curved extension and feet around the center of the spring, and as the gear turns, the spring does too. Pulling the car backwards activates an internal spiral spring, and because the motor inside is clockwork, this is possible. And this is called gear trend, and it's what causes the spring to wind up.
Hi, my name is Muhammad Ismail Hussen, and today I'm going to talk about the methodology. So methodology is critical in determining the project flow process. And in our process, the industrial engineering concept in improving the system has been applied for this case study, which is design of experiment or DOE application. So for the list of apparatuses that we use first measuring tape, toy car, tile floor, and lastly is concrete floor. So for the procedures, first we need to find a place, large place with tiles on the floor, and next we need to place the measuring tape on the floor and hold it together so it won't move. Next we need to place the toy car at a distance of 10 centimeter so that we can pull it back until the 4 centimeter mark and release it. And wait until the car stops. After it has stopped, we need to measure and record the distance traveled. After we have to record the distance traveled, we need to repeat the steps again so that we can find the average reading. So after we have find the average reading for the 6 centimeter pulling distance, we need to find the average reading for 12 centimeter pulling distance, and after that we need to record the data. And lastly, we need to repeat the whole process using the concrete floor. That's all. Thank you.
Hi and Assalamualaikum, my name is Muhammad Najmi, and now I am going to explain about the result and analysis of this experiment. For the experimental result, the data gained are placed in a table as shown, and from the data, we can plot the graph. Next is the application of DOE. For this experiment, we have two factors which are the type of surface and the distance of the car being pulled back. Each factor have two levels which are high level that we use plus sign and low level that we use minus sign. We set the types of surface as factor A, which is a categorical variable, and the distance of the car pulled back as factor B, which is a numeric quantitative variable. Then we assign the tiles and 6 centimeter distance as the low level, while the concrete and 12 centimeter distance as the high level factor. Next, we move to the data of the average total distance traveled by a toy car as shown in the table. So in this experiment, there are 4 runs to study the interaction between the factors. It consists of a combination of plus plus sign, plus minus sign, minus plus sign, and minus minus sign. The data is obtained from the experiment done. Then a design geometry is plotted as shown. Factor A is placed on the horizontal line and the factor B is placed on the vertical line. Next, the low and high factor sign are placed from the left to right and bottom to top as shown. For the outcome of this plot, the average total distance travelled by a toy car are placed according to its factor combination. Furthermore, to plot the main effect graph for total distance travelled by a toy car, we have to consider the average value of each level. Start with factor A. The high level average that we get is 117.78 cm and 93.98 cm for low level average. Then the difference between the high and low level average is 23.8 cm, which is the main effect of the total distance travelled by a toy car. For factor B, the high level average is 154.68 and the low level average is 57.08 cm. The main effect for the factor B is 97.6 cm. Lastly, the main effect graph for factor A and factor B are plotted as shown.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hanabi Abdulaziz. My metric number is CD 180239. And today I'll be presenting about the discussion for our group project. Okay, for this project, we will look at the total distance traveled by the toy vehicle on various surface as well as different distance the toy car is pulled back. It was seen on the both smooth and rough surface. The rough surface produces force that is preventing the toy car from moving. The force of friction is a force that causing the moving object to slow down. Friction is a force that opposes the sliding movement of two surfaces that are in touch. We will demonstrate the experiment and the application of design of experiment outcome in this part. The finding for the experiment revealed that on the tiles, the average reading of a total distance by a toy car is higher than concrete. We employ two factors on the overall distance driven by the toy vehicle, such as type of surface and the distance of the car is pulled back, to apply the design of the experiment approach. The concept refers to the set of tests that's including modifying the controllable input factor in order to find the corresponding impact of the output response. To explore the interaction between the component, a statistic desirable array combination of low and high level was generated for a total of 4 runs. A response factor, which is an average total distance traveled by a toy car, was also used to measure the effect of variable component in each run. A graph is used to illustrate the result. A horizontal axis represents the distance of toy car pulled back, while the vertical axis represents the overall distance a toy car has been traveled. The graph reveals that the experiment data increased linearly. To show the impact of DOE, we will use the main effect plot of total distance driven by toy car to interpret the data. Prior to the conducting of the experiment, we will carefully consider the combined effect or interaction between two elements. A toy car distance travel is discovered to rise with the distance of the toy car pullback. Similarly, the increase of the total distance traveled by a toy car by adopting a reducing friction type of surface has a good result. Both elements work together to increase the total distance traveled by the toy car, as illustrated in the graph. The mean value is increased linearly in both line graphs. For suggestion of improvement, this finding indicates that there is some issue with the experiment execution. It's vital to note that there's 3 different approaches to make the toy car travel faster. Allowing the toy car to move on smooth surface such as tile, spinning the blade multiple times before releasing the toy car, and allowing the toy car to go down ramp are examples of this method. As a result, we concentrate on examining the toy car on both rough and smooth surface for this trial. We determined that the toy car to move further, a smooth surface was preferable. The toy car can only travel a short distance when it's allowed to operate upon the rough surface. This occurs as a result of irregularity in the rough surface, which produces the friction. Because there is less friction on the smooth surface than the rough surface, the toy car vehicle should be able to roll further. Not only that, but the number of factors can impair the toy car performance. If the wheel is not properly aligned, they can wobble or jam. This makes it difficult for the toy car to roll smoothly.
Okay, in conclusion, the distance of the pullback toy car after being released on the tile is greater than being released on the concrete surface. The greater the distance of the toy car is pulled back, the further the toy car move forward after being released. To make a pullback toy car move further, the distance of pullback must be increased and the toy car must be released on the smooth surface because the weight will meet with a little resistance on the smooth surface. All the 4 objectives in this project has been accomplished. A special big thanks to our lecturer, Professor Madya Dr. Ibrahim bin Masud, for teaching us for the whole semester, and thank you everyone for watching.